Let's take a look at the following situation. Paul has a pocket full of cash. He has 17 bills consisting of only ones and fives. He has a total of $37 in his pocket. How many of each denomination does Paul have? Okay, so actually we can set this up as a linear system of equations that we'll be able to solve, so we can determine how many ones and how many fives he has. So let's go ahead and label a few variables. We're going to let x equal the number of ones, number of $1 bills, and we're going to let y equal the number of $5 bills. Since this is actually what we want to know how many of each denomination that he has, and he only has ones and fives. So x equals the number of $1 bills, y equals the number of $5 bills. Alright, so far so good. Now we need to set up a couple of equations. We want to set up a system of equations that describes this problem here. So the first thing we're going to do is we're going to let the number of bills, that's something that we know, we're going to let the number of bills be described by the following equation. Well, he only has ones and fives, so we know that the number of ones plus the number of fives equals 17. He has 17 bills. So we're going to say x plus y equals 17. All right. Nothing special about it, nothing fancy. This is just a simple relationship using what we know. Now our next equation, we actually know the value of these bills, the total of them. So the value of the bills is going to be described by the following equation. We know that the number of ones times the value of the one will give us one value, plus the number of fives times the value of fives. When we add those together, we get a total of $37. So we're going to say that 1 times x, or 1 times the number of ones, so just x, plus the number of fives times its value, so 5 times y. When we add these up, we should get a total of $37. This is a system of equations that we can solve, and if you look at it, we have the same variable in both equations that have an identical coefficient. They both have a coefficient of 1. So we can use elimination by subtraction here. So let's go ahead and do that. We're going to subtract one equation from the other. So let's go ahead and say x plus 5y equals 37. For some reason, I like putting the larger equations on top. This looks a little bit bigger. This makes more sense to me. We're going to subtract the second equation, or this equation, from this equation. So we have x plus y equals 17. Before we do so, we're going to distribute this negative sign in the second equation. So we're going to rewrite the first, equals 37, and we're going to distribute this negative sign. So instead of subtracting equation 2, we're going to add the opposite of equation 2. So the opposite of x is minus x, the opposite of y is minus y, the opposite of 17 is minus 17. And let's go ahead and add these two equations. So x minus x will cancel. We have 5 minus 1, which is 4y. 37 minus 17 is 20. And we can go ahead and solve for y by dividing both sides by 4, which will give us y equals 20 over 4 is 5. So we have a value for our first variable y, and y equals 5. So we can go ahead and plug this into either equation to find their variable x. Let's use the first equation. It's a little simpler. So we have x plus y, which is 5, equals 17. Let's go ahead and subtract both sides by 5. Those two terms will cancel. So we have x equals 17 minus 5 is 12. So we have the value for both of our variables. So let's go ahead and write our answer, because our variables are defined as what we want to know. We want to know the denominations of each type of bill that Paul has. So we can write that, let's pick a different color. We can say Paul has x equals 12. X is the number of ones, so we can say Paul has 12 $1 bills. He has 12 ones, and he has y is the number of fives, y equals 5, so Paul has 5 $5 bills. And that's all there is to it. So we took the information we know how many bills he has, and how much the value of the total amount of bills is. We have the total amount the total value of the bills, and we want to know how much of each denomination he has. So we simply set up a system of linear equations, and we solve those by elimination, in this case subtraction, to find out how many of each bill he has. So it's very intuitive. We'd do a few more examples like this, and we'd have a good handle on it, but just go ahead and go over this application so it actually makes sense. And always remember that the most important part is actually identifying the pertinent information, the keywords, and actually writing a couple of equations out of it that we can solve. So look over this a few times. In the next section, we'll move on to solving linear systems by elimination. But these linear systems aren't going to be so obvious. We're not going to be able to simply add or subtract one from the other. So I'll see you in the next video.